So see if you can graph that one. This is part 2. I'm jumping right into question number 4 because 1, 2, and 3 were pretty much like what we did already. Graphing sines and cosines. There's one more. It's got a little extra trick in it. So start by finding the period, amplitude, phase shift. Bless you. Same kind of thing as normal. Okay, so let me help. So this is the A. What's the B? 2 pi. Here comes the big question. What's the C? 0, not the 3. That's it. If you don't realize that, the ball game's over. So that's what's really important. Did you realize the C is the thing in the parentheses? That 3 is not in the parentheses. In other words, it's like this. It's like there's an invisible plus 0, and the 3 is the D. That's what you got to realize. Are you aware of that? Are you with me on that? So it's really different whether that last number that's added, subtracted, is in the parentheses or not. Why? Because then it's being plugged into the cosine function or not. Right? If I write cosine of x plus 3 versus cosine of x plus 3 with parentheses, that's hugely different. Why? Because here the whole x plus 3 is put in the toaster. That's why I made up all the toaster talk, because I realized people weren't thinking right about functions when I first started teaching these kind of higher classes. I realized they weren't getting it. It's really important. Here only the x is being plugged into the function, and the 3 is sitting on the counter next to the toaster, outside of the toaster, not plugged into the holes. Everybody see the difference? That really, really matters. That's not just for these. That's for, you move on into pre-calc and calc. Anytime you're dealing with a function, you want to be crystal clear whether that thing off to the right is in the function or it's outside the function. And it's only in if there's parentheses. Right? That's like the holes in the toaster. So those parentheses. So that's what they're testing on this problem, if you know that or not. So there's nothing. So there's an invisible C is 0. And that 3 is actually D. Remember how it was originally written? 2 pi x plus 3, like that. That 3 is not in the parentheses. So that 3 is the D. What is the D? What do I mean the D? What does the D do? Up, down. Remember, it moves it up 3. Remember, you grab the midline, and you move the midline up 3. That's what it's going to do. Remember that? So let me take it from here with you. So now, what's the period? 2 pi over b. You probably got that part right. 2 pi over b, 2 pi over 2 pi. That's just 1, huh? And then the phase shift, though you would have had that wrong if you didn't realize, that's going to be 0. Because minus c over b, again, the c is 0, so it doesn't matter what b is. It's just 0. B is 2 pi, but who cares? The phase shift is 0, right? Because the c is, there's no number added after the x inside the parentheses, huh? The 3 is outside the parentheses. All right, so now, so where's this graph going to start? Well, it always starts at the phase shift, 0. And where's it going to end? Well, wherever it starts, plus the period, yeah. So it's going to end at 0 plus 1. It's going to end at 1. So basically, we have a graph now. Let me kind of get this out of the way so we have room. 0. So we're going to have a graph that starts at 0 and ends at 1. That's nice and simple. Starts at 0, ends at 1. But he's going to be moved around, isn't he? So basically, he's going to be 0 to 1. He's going to be a cosine graph in that zone, a cosine graph between 0 and 1. But this plus 3, this moves the middle, it says middle up 3. We're going to move the middle up 3. So instead of the middle line being the x-axis, the midline, I think that's what I called it before, the midline. It moves the midline, the axis. How about that? It moves the axis. That's a better way to say it, huh? Moves the axis up 3. So instead of the axis being at 0, it's going to be 1, 2, 3. It's going to be right here. Oh, I'm going to run out of room. I better squeeze that in. I just looked at that 5. I got a long way to go. 1, 2, 3. There we go. So that's the new middle. So it moves the axis, moves the whole graph up 3. The easy way to do that is just move the axis up 3 and make everything around that axis. So it moves that's the new middle. So then what is that 5 going to do? That's above and below the middle by 5. Going down first. So go up 5, 2, 3, 4, 5. That'll be up to 8. So it went up 5. And it's going to go down 5. So it'll be down here at negative 2. So you go up 5, down 5 from the middle of 3. Does everybody see that? So the number off to the right, added or subtracted outside the parentheses, moves the midline, the axis, up 3. And then from that middle, whatever amplitude is in the front, that's how far above and below your middle you go. So from 3, go up 5, you're at 8. Go down 5, you're at negative 2. So that's where the graph's going to. You can make a box if it helps you. So the cosine is going to fit in this box. Whoops. My box is not so boxy. There we go. So it's going to go from 0 to 1 sideways and from negative 2 to positive 8 vertically, with 3 being the middle. I'm going to stick in that box a cosine graph, an upside down cosine graph. So start in the bottom, end in the bottom, go to the top in the middle. Bless you. There we go. Does that make sense on that? Remember all that stuff? We did it before, but it's been a while, and it's good to review. Questions I can answer on that? Yeah.
So then, when we put this into the graph, so then the plus 3 would, so it would follow on the 1.
Well, on the test, it'll be multiple choice. Yeah. So test, you'll just look for the one that looks the same. When you do it on the actual, enter it into the program, what is it called? They have a vertical shift. Yeah, vertical shift 3. Yeah, you got to do a vertical shift box. Yeah, you just type in 3. Is that what it is in a vertical shift box? Yeah. Okay. So it sounds like there's a box, and you just type in vertical shift 3. Goes up 3. Yeah, good question. But on the exam, multiple choice, right? Which maybe if I have a little time, I'll show you. Good. So that's a tricky one. So watch out. It really matters whether that number's in the parentheses or out of the parentheses. Okay. So number 5, they're going backwards. So they're giving you the graph. They want you to work backwards to the equation. It's either a sine or a cosine. See what you can do there. Give you a second. There'll be one of these on the exam. Exams just like to practice. Okay, so first off, is it a sine or a cosine? Well, look at where it starts. Starts here, huh? So it's got to be a sine. Right? Remember sines always starts in the middle, goes high, goes low, back to the middle. Right? You with me? Sine starts like that, goes back like that. Whereas cosine starts, starts high, ends high, to U, or maybe an upside down U, but doesn't start in the middle. Cosine either starts at his top or starts at his bottom if he's upside down. But he never starts in the middle. See how sine starts in the middle at the origin? So this has got to be a sine graph, and there's one side. Remember, you want to hone in on just one cycle and kind of forget about everything else, because that other stuff could confuse you. Is that good right there? So there's one sine graph. Starts right here. Like that. Goes from 0 to 2, right? That's one cycle of the sine graph. So we say, okay, it's going to be a sine thing. So it's going to be y equals sine of, whatever. Well, an a in the front and a bx. Like that. Okay. What's the amplitude? What's the a? Yeah, it looks like it's going up to 3, down to negative 3. So 3 sine bx. How do we find the b? Period is 2 pi over b. Remember the little period formula? Period's 2. Remember the period what is period? Width of one cycle. Width of one cycle. So how wide is one cycle? Well, it goes from 0 to 2, huh? So the width of one cycle is 2. The period is 2. Right? It's the width of a full cycle. And that's equal to 2 pi over b. Am I going too quick? Does that make sense? Period is always the width. It's how wide one cycle is. That's why I hone in on one cycle and forget about everything else. You always want to do that with the signs and all these graphs, you know. So the width is just 2. That's period. Solve for b. How do we solve for b there? I usually, there's probably a lot of ways. I just put it over 1, go diagonal, diagonal. Usually when I have fractions, I just cross multiply. I found that's easy for students. So like that, 2b equals 1 times 2 pi. So 2b is 2 pi. Last step, divide by 2. b is pi, isn't it? So this is 3 sine pi x. Here's our formula. That equation would produce that graph. Is that good? So I worked it backwards. So it'll be one of those. Practice that. So that's hard for you, you know. That's why you want to practice on that. Is that good? Yeah. Yeah.
So for
Chai,
B,
right?
Yeah.
Yeah.
So for B, do we have to do like that, or could we just plug in like the 2 to B and we just divide by like 2 pi? Like, you know how like you did for B, like you put 2 equals 2 pi over B,
Right.
and you did all of that.
Uh-huh.
So can we just plug in the 2 for B? Like,
Plug in 2, and then what? So
You're
you're
saying like the width of the cycle, plug in the number 2 at B, and then you can just cross cancel the 2, then it'll still be pi.
yeah.
Like you, instead of doing all that work.
So you're saying take 3 sine bx and put in the 2 there for b, right here where b is, and then what? Because of the 2, and then what?
And then do the period just like regular.
Period like regular.
So like
So
you
it's
would do
2
2
pi
pi over
over
2,
2.
and then you'd still get pi as b.
Oh, and then multiply by 2 pi over, we'll do what?
Because we know the cycle is 2,
Right.
so we would just plug in the number 2 at where B is.
He's talking about the period formula. To plug it into the period formula.
Okay, 2 pi over b is the period formula. Plug that in where?
So plug the 2 in as b. So like,
Plug 2 in right here, where b is.
No.
no.
Here?
Yeah.
Why am I putting 2 in there?
They're just asking if it would always work that way, that you would get the same answer if you just plug it in right there.
I don't think so. Yeah, no, I wouldn't try that. And unless, now let's move on. Come talk to me later, everybody, about that. I wouldn't do that. Just kind of like what the real exam would be like, multiple choice, you know. So, graph 2 periods of tangent. Hey, I won't give you E, none of the above for the graph ones anyway. There'll be some E's for the non-graph ones. But yeah, so you'll know it's one of those 4 graphs because I don't want you to be fooled by some weird little thing on a graph and think it's not the right one. So for the graph ones, there will be no E option. It'll just be those 4. It'll be one of those. You know it's one of those. It just matter which one. So, okay, so how do we do it? So what do we do to graph this tangent one? So did you catch the game plan over there? So in fact, let me write out the game plan here one more time so it's on the YouTube videos as well. So that is tangent always goes between, originally anyway, negative pi over 2 and pi over 2, and he does a snake going up between those. And then cotan is the same thing, but he goes from 0 to pi and does an upside down snake, right? And then secant over here has the same bounds as tangent, negative pi over 2 to pi over 2, but he does a U shape, like a parabola kind of thing, not really a parabola, but it's a U shape, going up, starting at a height of 1, or whatever his amplitude is. Cosecant does the same thing, but he goes from 0 to pi. He's a U shape, starting at 1, going up as well. And of course, the secant and cosecant, they could, like, next would come a U down, next would come a U down, U up, U down, U up, U down, etc. forever. Notice again that the two cofunctions both go 0 to pi, 0 to pi. Both the cotan, the cosecant, and the non-cos, the ones that don't have cos on them, tan and secant, they're just negative pi over 2 to pi over 2. So you want to put that in your 3x5 card. That's the bit. These four all have asymptote lines, don't they? Sine and cosine don't. And so the game plan, it's all about finding where the new asymptote lines have been moved to. How do you find out where they've been moved to? You just take whatever's inside the toaster, inside the parentheses, and you put it between the bounds and you solve. So coming back here, I say, here's what's in the toaster. So I take x plus pi over 14 and I put it between the bounds. What bounds? Well, the original bounds for tangent, since we're doing tangent, negative pi over 2 to pi over 2. Negative pi over 2 to pi over 2. And then you just solve for x. And you'll find out where the new asymptote boundaries have moved to. Does that make sense? It's always the plan for all four of these. It's the easiest way to do it. Math Excel has a different plan, but this is easier. So, all right. So, what do we do to solve for x there? X is saying I want to be alone. That's what X is always saying. He's a big loner. Pi over 14. Subtract pi over 14. Subtract pi over 14 from all three, huh? It's gonzo here. X is alone. So now we just need to work that out. How do we work that out? Common denominator, top and bottom by 7, right? So 7 pi over 14 minus really 1 pi over 14 is 6 pi over 14. Got to reduce that. 3 pi over 7. Going too quick? Not good. Just divide it top and bottom by 2. Divide by 2. Divide by 2 to reduce it. 3 pi over 7. Other side. Other side, I've got pi over 2. So I got the same thing here. Multiply top and bottom by 7. You'll get negative 7 pi over 14 minus pi over 14, which is minus 8 pi over 14. Reduce it, minus 4 pi over 7. Is that okay with all those fraction things? You see what I did? Just got common denominator, right? So minus 7 pi over 14 and minus 1 more is minus 8. Reduce that, divide top by 2, minus 4 pi over 7. So that means what? There should be a set of asymptote lines between negative 4 pi over 7 and positive 3 pi over 7. So where do you see a set of asymptote lines between those? Well, a lot of them have that. They pretty much all have that. I guess that did nothing for us. All right, they all have that. So what then? How do we find the, can you see it? I can go to a fresh screen where you can see things a little bit better. Oops. So remember we got, what was it, minus, I already forgot, minus 4 pi over 7, yeah. So minus 4 pi over 7, 3 pi over 7. But they have, like there it is. He's got it, 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 he's got it. They all got it.
We could eliminate some of them from going from positive to negative instead of...
Yeah, right. Tangent's got to go from up to the right, doesn't it? Cotan goes down to the right, but tan goes up to the right. So up to the right. So no way on B, he's going down to the right. No way on C, he's going down to the right. So B and C are out. Those are cotan graphs, aren't they? Or negative tangent graphs.
Yeah.
Either way, but they're not tangent. They're not what we're looking for. So it's either A or D. What's wrong with A?
Doesn't go through the center.
Well, maybe there's nothing wrong with A.
Is it...
Well, the angle of the line
Yeah.
On A.
Is it
is
stretched?
through,
On A, the line is...
Yeah, A just looks funny.
yeah, A and
It does. It just looks weird. But this is not easy, is it? It looks like D to me. D looks like a normal tangent graph between negative pi. A A is like moved way up or something. Yeah, I think they've moved A way up. Like that's the center of it up there or something. Yeah, they've moved it up. It's not A. So the answer is D. That makes sense? See how D's right, centered right between, yeah, D's right, hits right in the middle of those boundaries.
Yeah.
Whereas A is, see it's hitting way over here close to the left boundary because they moved it up. That's not it. Is that okay? See, that's your first experience with kind of identifying. They kind of takes a little bit of practice to get used to spotting the right one, even when you kind of know what to look for. Does that make sense? See how we distinguish that? Okay, so can you see that one okay? So y equals 1/3 cosecant x over 4. So same deal, grab the inside, grab what's in the toaster, that, and put it between the normal cosecant boundaries. And solve for x. So what are the normal cosecant boundaries? 0 to pi. Yeah. So put x over 4 right in there. Good, and then solve for x. How do I do that? How do I solve for x there? Multiply by 4, huh? Yeah, good job. Multiply through by 4 there. So that'll 0 times 4 is just 0. These cancel, and this is 4 pi. So the real cosecant graph should have vertical dotted lines between 0 and 4 pi, huh? So right here at 0, right here at 4 pi, okay? Good so far. Now what does the cosecant do between his boundaries? Well, he does a U-shape. He does a U-shape between his boundaries, doesn't he? So he's going to go like, now remember, where does he normally start? Normally it's at 1. But with the 1/3 in the front, he'll start at 1/3. So do you see how B and C are crazy answers? Because B and C, they've, well, first off, between 0 and 4 pi, it's not supposed to be down, it's supposed to be up. Now that one's up, but it's up there like, past 2. No way. So it's A. See how A is right between 0 and 4 pi? There's the dot, just a little bit up. It's A. B and C, they've shifted the graphs up or down. That 1/3 is not a shift, is it? How do you move a graph up or down? If you had a number added out here, like 2 or something, that would move the whole. Remember, numbers added outside the parentheses are what move graphs up or down. That's what they're doing on B and C. That's not right. That good? The 1/3 is just an amplitude. It's just how high above 0. 1/3 instead of 1. We good? Okay, you want to try that one? So we've got to take that inside, what's inside the parentheses there, and put it between the normal secant boundaries and solve for x. And you know what that -1's going to do, huh? It's going to move the whole graph down 1. We'll do that at the end. Do that at the end. Grab that. And the normal secant boundaries, the asymptotes, minus pi over 2 and plus pi over 2. And then you just solve for x. It's a little messy to do. Yeah, it's good we do this one. This is a hard one. So what's the first step to solve for x? Subtract that 3 pi over 4 from all 3. Multiply top and bottom by 2 on these guys, huh? To get a common denominator. Is that okay? So then we get minus 2 pi over 4 minus 3 pi over 4 and 2 pi over 4 minus 3 pi over 4. So that's minus 1 pi over 4 there. Minus 5 pi over 4 there. Good to there so far? And now how do we get rid of that 2? Yeah, you could divide by 2. That's, of course, okay. But when you have fractions that you're interacting with, instead of dividing by 2, what would be easier for you is just to multiply by a half. Just easier for fractions, you know. So that's what I would do. I would just, you can divide by 2 there if you want. Doesn't really matter. But out here, I would multiply by a half. That's the same thing as dividing by 2, right? Dividing is upside down multiplying. And that's just easier to deal with fractions that way. So these cancel. That gets x alone. Dividing by 2, same thing as multiplying by a half. And so what are we going to get then? Minus 5 pi over 8. And that's minus pi over 8. Is that okay? Can I help with that in any way? Is that making sense what I did there? And so that's our new dotted lines, huh? That's going to be our asymptote lines. So then we go to the graph, and we'll put that on there. So, okay. So that'll be between, kind of like that. So minus 5 pi over 8 and minus pi over 8. Between those two, well, those are our dotted lines. And what are we going to have between those two? What does secant always look like? It's a u, right? It's going to be a u. Yeah, and now we want to think about, right, we want to think about that whole shift thing. We want to think about the fact that this minus 1, that's going to move the graph down 1, isn't it? Numbers added and subtracted outside the parentheses. So normally, maybe it'd be helpful if I do the normal. Normally at up 1, you know, right there, there'd be like a u like that, huh? But if you move it down 1, then it'll come down to 0. And go up from 0 now, won't it? And then what about normally there's always a u up, u down, u up, u down. So the next one that has a u down normally is at -1, huh? Normally, the next one would be a u down at -1. But because the whole graph has been moved down 1, it'll actually go down to -2, won't it? So this will go down to some -1, -2. So it'll move the whole graph. See, the new middle is the -1. That's probably the better way to do it, huh? This is always the new middle. That's probably the best way to do any of these vertical shifts, you know. Whatever's added or subtracted off to the right outside the parentheses becomes the new middle. The new middle is -1. 1 above that and 1 below that is where the U-shapes are. So there it is. Is that good? Is it multiple? Go find it multiple choice that way. I don't remember. They're just giving me weird numbers. See, this is where multiple choice can be a little tricky. Okay, wait. They all look weird to me. Okay, let's go back. So this is why you want to like draw your own first and then kind of compare. So, okay, so what are we looking for? We're looking for a u that goes up a little bit left of the axis. And to the right, we're going to have a u like that. Okay, let's go back and see again. A little bit left. Okay, so A is looking good so far. Because there's a u. Yeah, I'm going to look at the numbers in a minute. I'm just going to look at general shapes first. So there's a u a little to the left. That's what we're supposed to have, a u a little to the left. I mean, it might not be right. B's no way. See how the u going up is like hitting the axis? That's not right. Right? The u going up is not hitting the axis. So it's not B. I like to eliminate things. No way B. Everybody see that? See how this u right here is hitting the axis? That's not right. See how this u is hitting the axis? No way. So D looks good. It's either A or D. You with me so far? Is this making sense? See how I eliminated B and C? A lot of it's elimination. And that's why I'm not giving you an E. There's no none of the above on these graph ones. It is one of those four, you know. So it's either A or D. So now, yeah, why are these numbers so weird? I'm not really sure, to tell you the truth. What are they doing with these numbers? Oh, we can figure out which one is it. Can you see now? Isn't it, it's got to be D by the vertical. Remember? This one's at a height of 0. That one's at a height of -2. So see, 0, -2. So 0, -2. Whereas this one's at -1, it looks like. That's not right. So it is D. Yeah, now why the weird number? So we know it's D because of those things we eliminated. Is that okay? Now why the weird numbers? I'm not exactly sure. Why are the weird numbers? What is that -3π/8? They're just kind of like sticking it there. They're not telling me what it is. Oh, you know what it is? It's the center where that thing hits. Yeah, it's this point right there. They're telling me that is -3π/8. Now, we don't happen to find those points. Yeah, see, this is what's difficult. We don't do it that way. We don't find where they hit. We find the verticals, right? They're not showing me the verticals. See, look back here. See, they're not even showing verticals, are they? So they're not showing me the verticals. So I know that's why it's a little confusing. We're using a different technique. Can you see that is correct, though? Because what's right in the middle? What's right in the middle of -1π/8 and -5? What's right in the middle of 1 and 5? 3. -3 is the middle of those 1 and 5. It is right. But see, that's kind of harder, huh? That's why I wanted to give you a little bit of practice on the multiple choice. But mainly I eliminated it by just the U shape doesn't hit the axis, bye-bye B and C, and then the vertical thing, so we knew it was D and not A. So you don't have to pay attention to those other numbers. Is that okay? So this takes some practice, some getting used to with the multiple choice thing.